There are discoveries that shake astronomy. Some confuse astronomers, while others challenge long-held ideas. And then there are the discoveries that seem to crack open the very foundations of physics itself. These are the kinds of findings that leave even the world's leading scientists searching for answers. They are the discoveries that make cosmologists pause, question their assumptions, and admit that the data they are seeing does not fit comfortably within current theories. According to this dramatic narrative, the James Webb Space Telescope has delivered exactly that kind of discovery. Webb has looked deeper into the universe than any instrument before it, peering beyond the so-called cosmic dark ages into an era when the first stars and galaxies were expected to begin forming. Scientists anticipated finding faint, primitive galaxies slowly emerging from vast clouds of hydrogen gas. Instead, Webb revealed remarkably bright, surprisingly massive, and highly structured objects that appear far more evolved than many researchers expected for such an early period in cosmic history. These observations have sparked intense debate about how galaxies formed and evolved during the universe's first few 100 million years. As more images arrived, each seemed to raise new questions about existing models of cosmic evolution. Rather than simply adding new objects to astronomical catalogs, Webb's observations challenged scientists to reconsider aspects of galaxy formation in the early universe. The telescope's discoveries prompted discussions throughout the scientific community about whether current models need refinement to explain these unexpectedly mature-looking galaxies. The story began with what appeared to be an ordinary object, a small yellow blob hidden among thousands of faint specks in one of Webb's deep-field images. At first glance, there was nothing especially remarkable about it. However, one feature stood out immediately. It appeared extraordinarily bright. Initially, astronomers suspected it was much closer than it seemed, assuming its apparent brightness resulted from a mistake in estimating its distance, something that occasionally happens when studying the distant universe. Spectroscopic measurements quickly changed that interpretation. The object's enormous redshift confirmed that it was indeed extremely distant. Astronomers realized they were looking at one of the earliest known galaxies, existing when the universe was only about 290 million years old. Yet it did not resemble the small, chaotic, and primitive galaxies predicted by many models. Instead, it appeared structured, massive, and surprisingly well-developed, resembling a mature galaxy in an era when only the earliest stages of galaxy formation were expected. That realization sparked widespread excitement among researchers. If even one fully formed galaxy existed so early in cosmic history, it suggested that galaxy formation may have occurred much faster than previously believed. Within days, Webb identified additional objects displaying similar characteristics. What initially appeared to be a single unusual observation gradually became a growing population of distant galaxies that challenged astronomers to rethink how quickly large cosmic structures can develop. Deep-field observations from the James Webb Space Telescope were intended to provide a window into the universe's infancy, a view of faint, scattered points of light representing the earliest stages of cosmic structure. Instead, when Webb focused its infrared instruments on some of the darkest regions of space, it found objects that appeared unexpectedly bright, compact, massive, and organized. Many researchers noted that these galaxies did not match the characteristics expected from the earliest protogalaxies predicted by standard cosmological models. What made the discoveries even more intriguing was their apparent abundance. Rather than identifying only one or two unusual objects, Webb detected many distant galaxy candidates from the universe's first few 100 million years. Several scientific studies have reported dozens of promising candidates dating from roughly 200 to 400 million years after the Big Bang. If many of these observations are confirmed, they may require astronomers to revise important details of galaxy formation within the widely accepted lambda-CDM cosmological model. Some researchers have openly acknowledged the significance of these findings. They have suggested that if even a fraction of these early galaxy candidates prove to be genuine, existing theories of galaxy formation will need substantial refinement. Rather than revealing a slowly evolving young universe, Webb's observations suggest that large, bright galaxies may have appeared much earlier than expected, raising new questions about the timeline of cosmic evolution. As if the existence of these massive early galaxies were not surprising enough, Webb also uncovered another puzzle related to star formation. In galaxies observed in the nearby universe today, only a portion of the available gas is converted into stars during any single period of star formation. This efficiency is typically far below 100% because complex physical processes regulate how gas cools, collapses, and forms stars over time. However, observations of several extremely distant objects suggested unusually high star formation efficiencies. Some analyses indicated that nearly all of the available gas may have been converted into stars within these systems, a result that would be difficult to explain using current models of galaxy evolution. If confirmed, such observations would suggest that star formation in the early universe may have proceeded under conditions very different from those seen today. These unusual objects do not behave exactly like typical nearby galaxies, and astronomers are still working to understand their true nature. Some researchers have proposed that they may represent previously unknown stages of galaxy formation or entirely new classes of cosmic objects that existed only in the early universe. Others believe additional observations and improved measurements may eventually explain these apparent anomalies within existing physical theories. Whatever the final explanation proves to be, the James Webb Space Telescope has already transformed our understanding of the early universe.